Hello, 8th grade math students. Mr. Lawrence here, and I made this little video to help you because we did the lesson in class today. This is a little review for you. So remember that if we're going to convert decimals that do not repeat, terminating decimals, it's really easy if we know our places. And we know that this 1, see this number here? This 1 is in the hundreds place, right? Hundreds, like 100, you know that. Right? Okay. And then we have the tens place. Guess I need an N on the end of hundreds. And then, of course, we have the ones place. Now, the place where some students get screwed up is after the decimal point. They don't know what the places are. They want to just say point. And the problem with doing that is you misunderstand what's going on in the mathematics. So the 4 is in the tenths place, and it has a THS on the end of it, tenths. Everything to the right of the decimal place has something like that. The 5 is in the hundredths. You can hear that THS, hundredths. And there's another D and then a THS. Okay, and then the 6, of course, is in the thousandths. Thousand. And then we're going to put a THS on the end of it. Okay, now what I'm going to do is when I read my decimals, and that's why I don't let you say point in class, for example, if it's this, I don't call that 0.27, I call that 27 hundredths. The way you know what to do or what to call it is based on the last digit. That last digit is in the second place, which is the hundredths. So you just read this number as 27, but then you stick the hundredths on the end. If you have 3 digits, okay, the 5 is in the thousandths place. There's a 0 here, so you just pay attention to 35, but you still call it thousandths. 35 one-thousandths, because the 5 is in the thousandths place. If it was like this, it's just as easy, maybe even easier. This would be 735 one-thousandths. Okay? Now, when we have those terminating decimals, they are so simple to convert. For example, this first one here says 4 tenths. Hopefully you know how to read that. Well, literally, that means 4 over 10, 4 tenths, just like that. Of course, I do have to simplify it, find the greatest common factor between 4 and 10, which of course should be 2. So I'll divide both the numerator and denominator by 2, and that will get me the fraction 2/5. And so what I'm telling you is that 4 tenths and 2/5 are equivalent. They have the same value. If I were to do long division on 2/5, 5 and a 2, right? And some of you need some practice with long division. Please come see me. It's too easy a skill to get wrong. Okay, I'd love to help you with it. Okay, 5 goes into 24 times. 4 times 5 is 20. I subtract, I get no remainder, I'm done. Look at that, I got 4 tenths. Not a surprise. Okay, the second one here, the number 2, okay, it's 22 100ths. So I'm going to write 22 over 100. And again, I want to simplify. Now, this one also will be divided by 2 because that's the greatest common factor. It's not always divided by 2. That's just in the example I picked. So that would be 11, and the denominator would be 50. Those do not have a common factor other than 1. So my answer is 11/50ths. I'm not going to do it, but if you did long division on 11/50ths, and you can practice that, those of you need to practice your long division, set up your box right, you better get 0.22, 22 hundredths. If you don't, you're setting your box up wrong. Okay, so finally, this third one. Now, if you want to, you can pause the video and try it on your own, but the intention of this video is just to go over the notes one more time for you. So I've got 225, but the 5 is in the thousandths place. So I'm going to put 1,000 there. Now, I need to simplify this. I know that 25 goes into both of those. If you think about it, $2.25, you can make that with a bunch of quarters. You could also make $10 with a bunch of quarters. Okay, so you're going to divide them both by 25. Divide by 25. And when I do so, my numerator, I think it's going to become 9, right? 9 quarters would be 225, right? I'm thinking the bottom one is 40. I'm almost positive about that. Let me take 1,000 and divide it by 25. Okay, and so that's going to go in 4 times, and that'll be 100. Yep, it's going to be 40. All right. Now, I'm not done unless I'm positive that there's no common factor between 9 and 4 other than 1. The only factors of 9 are 1 and 9 and 3 and 3. None of those except for 1 go into 40, so I am done. Okay. Now, the ones that have a little bit more work to them are the repeating decimals. And this is really some pretty amazing algebra here. Remember, first, we're going to let x equal 3/10 repeating. And then we're going to multiply both sides of this equation by some multiple of 10. How do I know what multiple? Well, how many digits are repeating? Okay, here I have 1 digit repeating. So I'm going to multiply by 10 to the first power, or just plain old 10. I'm going to multiply both sides by 10, so I'll get 10x on the left, and the right will turn into 3 and 3/10 repeating, just like that. Here's where the cool thing comes in. I really like this. The math geek in me just loves this. I'm going to subtract the green equation from the red equation. Now be careful on the left side. 10x minus x is not 9. That makes no sense. It's a 9x. Why? Because there's a 1x here. The x's don't cancel out. No, the 10 and x are attached by multiplication. Subtraction can't undo multiplication. So I'm going to get a 9x here. Now on this side, it's really easy because the 3/10 repeating cancels out with the other 3/10 repeating, leaving me just a 3. Getting the x alone, I'll divide by 9, and then x will equal 1/3. And there you go. Okay, number 2. Again, I'm going to let x equal 35/100ths, repeating. Right? I'm going to multiply both sides this time by 100, by 10 to the second power. Yeah, because there's 2 digits. You get 35 and 35 100ths. 35, hundredths repeating. And now I do that little subtraction trick. So I'm going to subtract the 1x and the 35 hundredths repeating. Doing so will get me 99x. And over on the right-hand side, I'm going to be left with 35. I'll divide both sides by 99. And then x will equal 35/99ths. Now, if that could be simplified, I would need to, but in this case, it will not be simplified. There is no common factor between 35 and 99 other than 1. All right, get myself a little more room here. This third one is a little bit tricky. You know, I said the number of digits repeating, but notice I don't get a repeating digit until that third one. So I'm not going to multiply this one by 100 like I did the last one. I'm going to multiply by 1,000. Okay, so I'm doing 1,000 x, and then that's going to equal 415, and then 1, 5 repeating. How do I know? Because when I multiply by 1,000, this decimal point moves 1, 2, 3 places to the right. And of course, there's a 1, 5, 1, 5, 1, 5 here forever, right? Okay. So now I subtract the green one. Uh-oh, I think I've made a mistake here. Hold on 1 second. Okay, sorry about that. I was making a little mistake. And I'm a little bit tired, and so I wasn't able to catch it, but I did a little bit of research, and I'm good now. Okay, so we are going to, first of all, we're going to multiply by 10x. And why are we going to do 10x? Because that's going to move this decimal point here and give us 4 and 15/100ths repeating. Now, we can't subtract this line x equals 4 and 415/1000ths with the 15 part of it repeating. We can't subtract that because the decimals won't line up. We won't have the 0.15 repeating on forever for the 15/100ths. So what I'm going to do now is I'm going to multiply x again, but this time by 1,000. Why 1,000? Because I'm going 1, 2, 3. Because if I can get the decimal point there, I'm going to have the 1, 5, 1, 5, 1, 5 on forever that I want. So I'm now going to multiply by 1,000 on both sides of the original equation, which will turn this into 415 and 15/100ths repeating. Now I'm going to subtract the green one from the red one. Okay, so I'm going to come here and I'm going to go minus 10x, and of course minus 15/100ths repeating. And you can see that these lined up. The trick was counting how many places I wanted the decimal point to move. For the first multiplication, I only wanted to move 1 place, so I multiplied by 10. But for the second multiplication, so that I would get that repeating decimal going forever and ever and ever, I multiplied it by 1,000, because that would move it 3 places. Okay, so when I do this subtraction over here, I got 1,000 minus 10, well, wouldn't that be 990x? Right, if I add 10 to that, don't I get 1,000? And over here, I'm just going to get a plain old 415, because the repeating parts of the decimal have canceled out. Okay, I'm going to divide by 990 on both sides. And this fraction is going to need to be simplified. Now, off the top of my head, I don't know. Oh, yeah, I do. No, I don't. I thought 9 went in the numerator, but it doesn't. So I'm going to divide both by 5 and see where that gets me. I might have to do some more simplifying, but I'm going to divide both by 5. So let me see. 415 divided by 5. Looks like it's going to go in 8 times. That's going to be 40. And then we have a 15 left. So it looks like the numerator is going to be 83. Okay. 990 divided by 5. Well, 5 is going to go in there once. It'll be a 4. That'll be a 59. Oh, silly me. I told you I'm getting tired. I'm so sorry about that silly mistake. Let me fix that right now. 1 times 5 is 4. Silly, Mr. Lawrence. I must have been thinking about my answer to my subtraction before and got ahead of myself. So that would be 4. And then I'll bring down the 9. 5 goes into 9. 49, excuse me. 5 times. Oop, my pen stopped working. There we go. Oh, I'm just having all sorts of trouble here. All right. 5 goes into 49 9 times. Yeah, so that would be 45. Then we get a 40, and then 5 is going to go into 48 times. So the denominator of my fraction is going to be 198. Okay, and I'm pretty sure that that's simplified as far as it can be. 83. I'm not positive if 83 is prime, but I think it might be as I look. Off the top of my head, I'll tell you what. Here, let's go to Google. And let's see what Google says. Let's ask, is 83 a prime number? And let's see here. Yep, it sure is. And so when it's a prime number, if you recall, that means that the only factors it has are 1 and itself. And I know 83 is not going to 198, because if I multiply 83 by 2, I'm going to get 169, and then there wouldn't be room for another 83 in there. All right, this was just a little video to go over what we went over in class today. All right, Mr. Lawrence signing off. Have a good night, everybody.